Hey everybody, today we're going to be learning about the quotient rule of exponents. Let's get started. The quotient rule says that if we have one power being divided by another and the bases are the same, we can keep our base the same while subtracting the exponent of the denominator from the exponent of the numerator. The reason why this works is because exponentiation is repeated multiplication. I'm going to draw this first power in red and this second power in blue. In our numerator slot, we have x to the power of 4 being divided by x to the 2, which is x times x. X divided by x is just 1, and so these would cancel out, and similarly, our second pair of x's would also cancel out. Since there's nothing left in our denominator, our equation simply becomes x times x, which is x to the power of 2, which is the same result we would have gotten had we applied our quotient rule to our original equation. In this example, we have x to the power of 2 being divided by x to the power of 5. Let's double check our quotient rule requirements. Our powers are being divided by each other, and our powers have the same base, in this case being x. Rewriting our equation with the quotient rule, we have x to the power of 2 minus 5, which is going to equal x to the power of negative 3. We're going to apply something called the negative exponent rule, which says that we cannot have a negative exponent attached to any of our powers. The way that we handle powers with negative exponents is by taking the negative exponent and turning it into a positive while placing the entire power attached to the negative exponent in the denominator slot of a fraction, where the numerator is 1. Let's try adding some coefficients into the mix. In this equation, we have 4x to the power of 4 being divided by 2x to the power of 2. Our equation is equal to 4 over 2 multiplied by x to the power of 4 divided by x to the power of 2. When we divide 4 by 2, we get 4, and when we apply our quotient rule to x to the power of 4 divided by x to the power of 2, we get 2 multiplied by x to the power of 2, which is our final answer. How about an equation that features more than one variable? Well, we can still use our quotient rule because our powers are being divided by each other, and we have pairs, and we have sets of powers with the same base. Rewriting our equation is equal to the product of x to the power of 5 divided by x to the power of 2 multiplied by y to the power of 3 divided by y to the power of 4. We can apply our quotient rule twice, once for each variable, which would give us x to the power of 5 minus 2 multiplied by y to the power of 3 minus 4. So after applying our quotient rule to x and y and multiplying x and y together, we have x to the power of 3, y to the negative 1. But remember our negative exponent rule, which says that we cannot have negative exponents. So to resolve this, we need to turn that negative exponent into a positive exponent while placing the entire power attached to the negative exponent into the denominator's slot of a fraction. Let's try an example with fractional exponents. In this example, we have x to the power of 3 over 2 being divided by x to the power of 1 over 2. We are able to use the quotient rule for this question because our powers are the same, and we're dividing one of our powers by the other. After applying our quotient rule, our equation is going to look something like this. Now remember, when we're subtracting two fractions together, we need our denominators to be the same, which in this case they are. And so our equation is going to look something like this. And of course, 2 over 2 is going to equal 1. Our final answer is x over 1, or just x. Okay, and that does it for today's video. If you made it all the way to the end, congratulations and great work. Like and subscribe if you found this video useful, and share with a friend who you think might find it useful as well. Take care.